Okay, welcome back. Now we're going to continue the session with a talk by Adrian, a contributor for scikit-learn, and with a background in bioinformatics, talking about let's exploit pickles with scopes. We're very curious about that. Sometimes there is also some live coding going on, so the stage is yours.
Thank you very much.
Thank you. Welcome, applause for Adrian.
So we're going to talk about Pickle and what goes on there, and what maybe we could do that in certain cases. I'm Adrian. You can find me on GitHub or on Mastodon. A bit about me. I did kind of interpretable methods for cancer diagnostics in my academic life. I did some machine learning consulting, joined the team, did algorithmic privacy and fairness. I do mostly open source, work on scikit-learn, fairlearn, skops. But that's the boring part. What can we do with Pickle? Let's import Pickle, and let's load this byte string, which is a valid Pickle string. What happens? What do you think will happen if I just load this? I'm only loading the Pickle file. I load it. It doesn't print it. It echoes it, even worse. As in, it is doing echo hello world in a shell. Really bad. So I guess my talk is done. Pickle is bad. If you want, you can leave now. But there's a little bit more to it. This relies on OS being available when you're loading something. You could restrict that. You could have your own fancy restricted unpickler. You can inherit from unpickler. Then you can inherit this find class. And then you can decide whether something inside the module should be available while unpickling or not. So you could say, like, well, OS shouldn't be available. Eval shouldn't be available. Exec definitely shouldn't be available. It helps. It's not perfect. At some point in Python, oh, I love this thing. They realized it's not good enough. There used to be some safety checks for Pickle. And I'm going to just read this text out loud. This feature gives a false sense of security. Nobody has ever done the necessary extensive code audit to prove that unpickling untrusted pickles cannot invoke unwanted code. And in fact, bugs in the Python 2.2 pickle.py module make it easy to circumvent these security measures. And they say just like don't unpickle things whose source you don't trust. And that is the state of things now. So let's study a little bit more what Pickle really does and what are the components when we're dealing with Pickle, Pickler, and like Pickle files. You have the Pickler when you're dumping something, then you have unpickler when you're loading something, and then you have the opcodes, the instruction set. And a lot of interesting things happen there. To start, the two methods, magic methods that Pickle uses are set state and get state. You can implement them from Python 3.11. They are implemented in objects, so pretty much everything has them. Let's have some fun with them. I'm going to define a class. It doesn't have anything in it except get state and set state. My get state returns a dictionary, and my set state sets attributes on self based on whatever I have in that dictionary. And if I just dump an instance of C and then load it, I would have this A, because this dictionary has A, and then I'm setting an attribute here which would be A, value 42. If I run that, object.A would be 42. Does that make sense? Any questions? Shout out questions like at any point. I don't want to lose you. We can look into that a little bit more in detail. There's this thing called Pickle tools. You can kind of disassemble what you have in your Pickle. And when you look at it, you can kind of understand what's going on. There is this object C in main. We are setting a value 42 to an A here. OK. What happens if I save this in a file and I try to load it? Does it work? Yeah, it works. What happens if I try to load the same thing in a new process? Well, this happens. I try to load the same thing. It tells me that I don't have C in module main. So what loader is really doing is it says, like, okay, like I'm supposed to be loading this instance and then set the attributes on it. So it tries to do that, but the class C was defined in the this main module in the other file. It doesn't exist here. It says, well, import error kind of thing. You can use, I think, Cloud Pickle actually circumvents this, but you're basically saving code if you're doing that, so it's even worse. Another really crazy thing that Pickle uses is this magic reduce method. It returns a tuple of up to size 6. The first 2 are mandatory if you implement your own reduce. The first one is a callable object that will be called if I want to construct an object. So like I have an object, it's a fancy one. Pickle wouldn't by default know how to construct it. I implement reduce. I tell Pickle that this is how you can construct it. And then the second argument would be what Pickle should pass to that constructor or to that method that would return a constructed object or half constructed object. Because after it's constructed, then it would call set state on it. What I can do is I can have an object, and reduce would return print as constructor, and I would print something. So now, if I look at it, this is what it is. The whole Pickle file is it's a print, and it has an input. There is no trace of this object D, because I just didn't return that. And if I try to load it, it prints something. It doesn't return anything. It returns none because print is returning none. But of course, I could do worse. Instead of printing something, my constructor could be os.system, and then I could echo something into a file. And I'm being nice here. You could also do things like do an SSH to a remote server, or do a reverse tunnel to a remote server. So everybody who would load your Pickle file would have a connection to your server, and voila. And if I look at it from POSIX system, it just does this echo. Really nice, really fun. And if I try to load it, I would have that file. Now I do have that file in my file system. Really nice. So this is a lot of the attacks are based on this. You even have tools where you can get a Pickle file and inject something, a malicious code, into that Pickle file. So when the user would load it, they wouldn't notice any difference except that there's a side effect to loading that Pickle file. And they still get their model, their array, whatever they saved. There are other types of attacks. You have a lot of unhandled exceptions. You can do protocol downgrades. That's why here you have highest protocol among opcodes. It's not what is. You can do a lot of funny stuff if you construct your Pickle file yourself. You can do Pickle bombs, but then there are things like opcodes that Pickler never uses, but they exist. There's this DUP which duplicates the top of the stack, and pretty much if that exists in your Pickle file, somebody has tampered with it, because the Pickler would never produce a Pickle file with it. Why does it exist? And then you can abuse the parser, you can corrupt the stack. There is this really nice place, this repo PickleFuzz, with a lot of really nice attacks. These are the lists of exceptions. You can do a lot of really fun stuff. I love going through these. Another thing that what people have been trying to help in this space, it's a really funny space. Some people started doing this pickling library, and you can get a pickled load, you pass it a pickle, and it gives you something that you can pass to AST, get the abstract syntax tree, and then you can print that. So it basically gives you a Python code which would be the equivalent of loading the pickle. Because Pickle is not data. When you unpickle, you're running code. So you can be like, okay, in a human readable form, can you tell me what the code is that I'm running when I'm loading a pickle file? For example, here, if I'm dumping a list, this is what you get. Kind of readable, nice. Maybe you could look at your pickle files this way before loading them. If I look at some of the more funny ones that I have here, like this one that was doing an echo into a file, you clearly see that there's some like funny things happening there. So cool, maybe not too bad. And if I look at this like C1, you see clearly that it's like calling set state on A42, which was the result of get state. So like it can be very readable. And so on and so forth. But now let's do a very simple linear regression and try to dump that and look at the file, look at like the readable version of it. I'm gonna dump it and then load it. This is what you get. Not that readable. I mean, you could try, but not really. And this is just a single linear regression. So this is not really a solution. For a while, I truly believed that the solution is to just like give people this like tool that they can look at their pickle files. But pickle files are complicated. No way that I can like ask people reasonably. It's like as if like I ask people to read all the like the AGB, these things that you click on the internet. That yes, I agree with all your things, privacy terms. Like as if I accept people to actually read them. And people don't. So what we did was we were like, we don't want to redo Pickle. Oh, any questions up to this point? Good. I have lost everybody. We're like, we don't want to redo Pickle because by definition, kind of, you would have the same issues, but we want to have a more restricted, more limited scope kind of dumper that would like kind of dump stuff for you, persist stuff for you. It would work for certain use cases. The use case that we started working on was things around scikit-learn, NumPy, like things that are like in the statistical machine learning scope. The same issues exist if you're doing deep learning, but TensorFlow has its own format, which is not Pickle. PyTorch had a format which used Pickle in like inside it. So it was the same issues, and they are working, or last I checked, they were working on like an alternative format. And this is kind of the same effort, but for scikit-learn based kind of models. It doesn't work only on scikit-learn, it works on a ton of stuff, but that was our initial scope. And we're like, okay, the API is pretty similar, you just load something that you dump. Let's try to do that on D. It raises, because it tells you, you are trying to load a main.d, and I don't really know that. Are you sure you want to load this thing? So I would have to tell it that, look, I actually like trust this thing, please load it, and then it would load it. Or if I really, really trust the source, like it was myself who persisted this thing maybe, then I can be like, just like trust everything. So what are we saving here? Let's check some things. I'm going to save this D. It's a zip file with a JSON schema. Really easy. And it does store the information that we need. I'm like, well, I'm like loading class D in main, and I'm storing certain things in it, but nothing's in there. Like the content is like empty. It's nice. If I try to do that with the other file, I see that I have like a list in here, easy. Not much, but if I look at the one, where was it? Oh, what happened to my Firefox? Gone. Well. where were we? Right, here. Let's look at the one from scikit-learn. It is like you do have that JSON schema, but you also have a bunch of NumPy files. So this is what we do, like really simple, nothing complicated. If I see, I look at my objects. If I see some NumPy data, which is like mostly the case, I just save them using numpy.save, and then I load them and I attach them to my object. Everything else is attached to the object itself in that JSON. The trick being that numpy.save has this like argument allow pickle, which is by default true, so we set it to false. If the D type of your NumPy array is object, NumPy cannot save it. It has to pickle it. So if you do numpy.save on an array which has D type object, you're basically pickling everything. At least numpy.load has allow pickle false by default. So if you have something which is D type object, you save it, you load it, it fails. You have to say, yeah, no, I know, load pickle. We don't allow that. What we do is that if we see objects, we try to persist it ourselves with like our own way. And of course, like if you try to load it, it works. Nice. How does it work? We use new to construct an object, not init. And then we use getState and setState to pass things to them, which means we don't use reduce. So like if you have an object, it's your object which is going to be created. Then if you have a new which is not the default and it requires arguments, it wouldn't work. As I said, it does not work for everything. That's not supposed to be the case. Well, we implemented special case for a lot of things that we're like, yeah, no, we should be doing that, like dict, set, list, tuple, type, slice. And then we have some special code for scikit-learn's C extension types. We do use reduce there, but it's not like we take the output of reduce and we trust it. We take the reduce to get the arguments, but we choose the argument that the constructed that we already have. It's like kind of hard-coded there. And what happened was another library came and I was like, hey, like I have some C extension types, it doesn't work, can we add it? So they had a PR, they added, it's like, again, like hard-coded there. It's not ideal. We have to have like kind of a protocol to support that, but it's not super easy because of the way that Python works, because most people who have C extension types are creating them using Python. And in Python, if you have a C in it, then it doesn't produce new. So if I have an object that is like given by me from Python, then it just doesn't have new, I can't construct it. And then when I'm loading it, I don't load anything, I don't construct anything, I just look at my schema and I'm like, what would I be loading? And I look at it and I'm like, okay, like would I be trusting these things? If not, I don't load it at all. If yes, then I start constructing them. There is a nice web app which you can use if you are using the latest scikit-learn version to try, like dump something and try to convert it, like it wouldn't be on your machine. You load something and then you see if it works or not. If it doesn't work, we would love it. Send the pickle file to us. We try like to fix things. But it has been working on most things. Is it safe? No, no code is 100% safe, really. So we didn't really actually solve the problem. But we kind of helped, we hope. You do have zip vulnerabilities because it's a zip file, like zip bomb. There are some exceptions raised there kind of by design, so you need to know that. You can have, again, like very large objects. So certain attacks still exist. But at least the hope is the user wouldn't be able to run arbitrary code on your machine. As I said, if you have a fancy new, then it wouldn't work. But it does work already on XGBoost, LightGBM, and a lot of like CatBoost and a lot of other libraries because they kind of return a byte array and they load their byte array, and we save the byte array. What are we gonna do? So there is like it should be convenient for users. So things that we know are kind of safe in libraries that we know, like SciPy, NumPy, scikit-learn, they should kind of be trusted. The user shouldn't be making those decisions. We still don't have memory mapping and certain speed and performance improvements for loading arrays, so it would be slow. So if you have a use case where you want things to be slow, load this file, then convert it to Pickle, then you know you were the one who converted it to Pickle, and then use everything else based on Pickle, which is much faster than like loading this file. And we should work on a public protocol which will allow people to kind of be supported without actually sending a PR to our repo. What do we need from you? Well, test it, break it, and submit issues. Thank you.
Thank you, Adrian, also for the live coding. Are there any questions for Adrian about also scopes, or if you try to handle Pickle in other ways? Or is there anything that you want to add, perhaps about the use of scopes or other ways that people here can help?
This project started last year at EuroSciPy. We had a conversation with some people about this issue, and the challenge. This was a challenge. Some people said, "No, you can't do it." I was like, "Well, we can try." So I went and tried, and now I'm reporting back.
Great. Super. There is a question there.
Thanks for the talk. I wanted to. So, do you think that it would be useful to have a way to sign the pickles when you dump it, and then like kind of make a hash of the pickles, and then people can load it if you provide the right hash, for instance?
Yeah, that is so.
We have that options.
And like trusting the signature is, you can do that on any artifact that you have, and there are people who try to do that on wheels or on like any kind of artifact. It would work on Pickle too if your source of the hash is not the same source as your file. Because usually what you do, for example, I go on the kernel's website and I download like my kernel and I check the hash against that. Or I download like my operating system's ISO, but I also get the hash from the same source and I check if it's the same hash. Usually that would mean that I'm only checking against corruption, not really checking against like trusted source. You would have to have that third party. If you can handle that, if you can like manage to have that kind of third thing, which is not, the infrastructure is different and the attacks would have to be like on both of them, then sure, it brings value.
Thank you. Is there any other questions? Or anyone that have a challenge for Adrian for the talk of next year? Okay. Okay, last chance. 3, 2, 1. Okay, so thank you again, Adrian.